Green iron gets the go-ahead in Germany, and Cummins teams up with Taylor Machine Works to leverage their hydrogen internal combustion engines. I'll go over all of this on today's Hydrogen Podcast. So the big questions in the energy industry today are, how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast. In a press release on August 11th, pilot plant for the production of green iron went into operation. A new type of plant for the climate-neutral production of iron went into operation in Lingen on Friday. Lower Saxony's Environment Minister, Christian Meyer, and Lingen Mayor, Dieter Krone, pressed the symbolic red button to start a so-called rotary kiln. According to the operator, the pilot plant will use carbon-neutral hydrogen to produce pig iron from iron ore, which can then be processed into steel. However, green hydrogen will not be available in Lingen immediately, but only in a few months. The energy company RWE is currently building a pilot plant for the production of green hydrogen with a capacity of 14 megawatts on its power plant site in Lingen in the immediate vicinity of the direct reduction plant. According to an RWE spokesman, this should go into operation at the end of the year. Lingen's geographical location is favorable for the onward distribution of the hydrogen to steelworks in the Ruhr area or to Salzgitter in eastern Lower Saxony. Electricity from wind farms in the North Sea is to be used. The system is a joint project of the startup company CO2 Grab, High Iron, the steel manufacturer Taylor, and the energy supplier RWE. The state of Lower Saxony is funding the project with 3 million euros, this according to Meyer. So far, coking coal or natural gas has been used for iron production. However, a lot of carbon dioxide is released in the process. The steel industry is the sector with the highest proportion of greenhouse gas emissions in German industry. This is again according to Meyer. It contributes to around 6% of total German emissions. In a quote from Meyer, the decarbonization of pig iron production therefore plays a key role because this is where the greatest potential for reducing emissions lies. The construction of a network of green hydrogen in Lower Saxony shows that industry will also be possible in the future. Lower Saxony is the federal state with the most wind energy. Again, according to Meyer, industry needs hydrogen, so we need renewables. The Lingen plant will also serve as a test facility for a steel mill planned in Namibia. In a quote from Stefan Lachman, shareholder of the High Iron Network, in Namibia, with the support of the Federal Ministry of Economics and Climate Protection, we are currently setting up production on an industrial scale. In the long term, production on an industrial scale is set to be up there with the aim of producing up to 2 million tons of iron annually for the German steel industry. Again, according to Lachman, this plant is to be built next year. And according to CO2 Grab, project manager Simon Brugge, the iron ore in Namibia is to be converted to iron directly at the iron ore mine, which would save transport routes. A special feature of the new process in Lingen is that the water produced during iron production can be reused and excess hydrogen can be fed back into the process. Again, according to Brugge, to keep the process going, you always need a bit more hydrogen than the chemical formula says. With the methods that have been used to date, excess hydrogen has to be burned after the process. The new process is therefore also more efficient when it comes to the use of hydrogen. Okay, so green iron is back in the hydrogen conversation. Previously, we've talked about the hydrogen revolution in the steel industry in Norway, and now it's iron in Germany. Now, what I find interesting about this announcement is they're stating that the hydrogen slated to be used initially will be carbon neutral, which I'm assuming will be either SMR or ATR with carbon capture and storage. I know this piece states they'll transition soon to electrolytic hydrogen, but I won't be surprised if this plant continues to run on that same carbon neutral hydrogen because it's either A, the electrolytic hydrogen production is falling behind due to either regulatory or technological hurdles, or the carbon neutral hydrogen is vastly cheaper. Time will tell, but luckily this project is progressing rapidly, so we should know the outcome by the end of the first half of 2024. Next, in a press release on August 10th, Taylor Machine Works and Cummins announced plans to integrate hydrogen engines into Taylor lift trucks and container handlers. Cummins and Taylor Machine Works, a leading American manufacturer of heavy industrial lift equipment, announced a signed letter of intent with plans to integrate the Cummins 6.7-liter and 15-liter hydrogen engines into the Taylor product line. This collaboration will help realize the decarbonization goals of industrial steel, wood products, concrete, oil and gas, and port operations markets. For 96 years, Taylor has been committed to meeting the material handling needs of their global industrial customer base, while focusing on its own generational workforce and surrounding communities. Cummins engines power a large portion of more than 100 different models of lift trucks manufactured by Taylor for the heavy lift industry. Taylor, along with their valued industrial partners, has undertaken the challenge of manufacturing lift equipment that will not only serve heavy material handling needs, but also bring positive change to neighboring communities. Beyond Clean Lifting, which is their commitment to the sustainable future, highlights Taylor Machine Works' efforts to develop low and zero carbon solutions across the entire product line. This effort includes battery electric trucks, hydrogen fuel cell trucks, and now hydrogen internal combustion engines. And a quote from Matt Hillyer, Director of Engineering, stated, "We're excited to announce our collaboration with Cummins to integrate hydrogen internal combustion engines into Taylor products. This partnership signifies their commitment to a sustainable future, enabling them to offer reliable, cost-effective, zero-carbon solutions for heavy industrial lift equipment, reducing carbon emissions without compromising productivity. Hydrogen combustion engines will create a zero-carbon fueled solution that provides cost-effective equipment for high load factor, high utilization applications. Key benefits of using this technology include enabling a more timely solution to reduce carbon emissions without sacrificing productivity. Adding hydrogen internal combustion engines to the mix of zero-carbon solutions will also reduce the load required from already stressed utility grids. Finally, commonalities with traditional internal combustion equipment will provide solutions that are dependable as well as easy to service and maintain." Antonio Leitao, Cummins Vice President of Off-Highway Engine Businesses, said of the plans, "Cummins is pleased to be working with Taylor Machine Works on hydrogen solutions for their equipment. We see hydrogen internal combustion engines as a solution to help drive sustainability improvements in our industry. Hydrogen power will help both OEMs and end users looking to make carbon emission reductions on their paths to net zero." Okay, so a great new hydrogen application announcement between Cummins and Taylor Machine Works. While it's not new to use hydrogen fuel cells in industrial heavy lift vehicles, it's very interesting to see Cummins leveraging all of their work in hydrogen combustion engines and applying it in this segment. And also to see the broad reach that this will have, as noted in the press release. The two companies through this venture will target the decarbonization goals for industrial steel, wood products, concrete, oil and gas, and port operations. Effectively, any industry with heavy lift needs. Now, like I said, hydrogen fuel cells have a special place in this world when it comes to heavy lift machinery. So it's interesting to see hydrogen ICE making its way into this segment. I understand the allure. The ability to shift to a carbon-free fuel while still maintaining a large amount of parts previously used for gas and diesel engines is a big win, but I can't help but go back to what I've discussed in the past. How are they handling the fuel storage issue for hydrogen ICE? Now, perhaps in this application, it's not an issue, and if that's the case, I can see these machines finding their way into every possible application in a very short time frame. All right, that's it for me. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. So until next time, keep your eyes up and honor one another. Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.